we are going to cover a few topics that are of great interest in this mobile-driven world. The first is achieving automation on mobile and what makes it so hard. I'm going to hand over to Mark Mashburn, who is the Kobiton sales engineer, and he's going to demonstrate the next three topics: how to generate a full Appium script, how to perform scriptless automation within Kobiton, and then how to capture some of the functional issues automatically from Nova. And then finally, I'm going to talk through some different scriptless and AI-based tools in the mobile space, and compare and contrast the different capabilities of mobile automation in the mobile scriptless world. So let's go ahead and get started and talk about why achieving automation on mobile is so difficult. For many of you who do automation today, this will be quite apparent and obvious, but I'm going to go through and switch over to my browser and show a demonstration of what it's like to create an automation script. So if I go in and I'm going to go ahead and log out of here and log in under my ID. This is our Kobiton portal interface. And I'm going to show you typically what happens is, and many users will, when you're creating an automation script, you go through this process. You have to open up an editor like IntelliJ, and then you'll typically use like an Appium Inspector tool, but Kobiton has that capability embedded within the product. So I'll use that since it's much faster than the other ways of inspecting elements. Let's see. So I'm going to launch this Google Pixel 6 Pro. And does this one have, Mark, do you have one of the Appium Inspector enabled devices ready?
Yeah, this Note 10 Plus should do what you're looking for. Top
okay.
right hand.
Okay, great, thank you.
Yes, sir.
Sorry, we have a few different versions of the product. So this one has the inspector enabled, and typically as an Appium automation engineer, if I go in and install an app, let's go ahead and search for the Vroom application. This is the same app that Mark will be using later to do the scriptless automation demonstration. Once this is installed, now as an automation engineer, I can go ahead and inspect elements, and in doing that, I click on Capture Inventory, and in here I can go in and choose which elements I want to interact with. If I want to select it on the screen, I can do it here. And you can see just by going through, I can capture these elements. It shows the element over here. I can show the attributes, and then I can choose the XPath or other Appium selectors. So then I paste this into my Appium script in IntelliJ, and I go through that process step by step. So now I switch off of the inspector mode, and then I can start searching. I go to the next step. I click Capture Inventory. I choose the element that I want to interact with in my Appium script, and I go through that step by step. So there's this back and forth between the manual session interaction, going to the next step, choosing the element I want to interact with, copying that into my system cache, and then pasting that into my Appium script. It's with Kobiton's inspector, it's pretty fast. With Appium Inspector, that whole process takes about 3 times as long, and it's wrought with just step-by-step, time-consuming tasks. If you don't have Appium Inspector, it takes about 3 or 4 hours to set up. Not too difficult, but something to go through. So that's what inspecting on mobile in the best case scenario looks like. And for those of you who have inspected elements on browser, it looks a lot. It's much easier, right? So I can just go in here, and I can go into View, Developer, Inspect Elements, and that's all you have, right? Chrome has the inspector embedded within it. So switching back, that's the process for creating automation scripts in using Appium the traditional way. Now, I want to talk through what's different specifically about automation on desktop browser and mobile. You go through and you can select your elements on Selenium, choose entity interactions. You have about 3 main browsers. In the mobile world, you've got hundreds of different device models and operating system versions. So it adds a much higher level of complexity. That process I just showed you is trivial in desktop browser. The big differences are these 3 points. Within desktop browser, there are standards, right? The W3C has a specification for how the XML is rendered within the browser, and all major browsers adhere to those standards. That makes writing Selenium scripts much easier, because you know that what is rendered on one browser is rendered the same way in other browsers. In the mobile world, that's not the case. It is a wild west in terms of rendering elements. Each device manufacturer can render how they want, and can render differently on different operating system versions. And for them, since they're the manufacturer of the device itself, that is a competitive differentiator for them. The second is the time to capture. In the desktop browser world, you're rendering the actual XML or the HTML in milliseconds. In a mobile world, that rendering and the ability to capture that typically takes between a half a second and a second per test step. This makes it much more difficult to do it as part of the manual process, and we'll talk about how Nova does that very quickly in order to help with the scriptless automation. And then the third point is accessibility, and I don't mean that in terms of the 508 compliance. I mean that in terms of how easy it is to inspect elements on browsers, right? You saw all I had to do was view on the menu item, and I can inspect elements. There's a lot of overhead associated with doing this on mobile. So the next, if you sort of look through on mobile, this is an example of Appium Inspector. It requires a third party, it's slow, it's external, and then you have all of these issues that I've already talked about. And in addition to these, that you don't have the constant pop-ups that appear and oftentimes cause Appium scripts to fail when you've got the, Apple would like to upgrade to 15.3 of your operating system, right? That's a pop-up that is unpredictable at times. Amber alerts cause problems with automation running, and entitlement prompts that differ from release to release of of the operating system. Often that causes additional problems, and we'll talk about that in more detail later. So now I'm going to hand it over to Mark to go through what this looks like with Nova.
Thank you, Frank. Let me make sure I am sharing my screen here. So what I'd like to do is create a quick manual test with several steps, and then we'll be able to immediately generate an Appium script from that test, and then run that manual test against several other devices using our scriptless automation. So I will launch this Galaxy Note 10 Plus. And install my application. And just for demonstration purposes today, I'm going to do several different clicks and swipes just to record a couple of different steps for this test. And then once I've completed those steps, I'll exit my test session. So I'm taken to my session overview, and we'll in just a second have a real-time video of that test that I just ran. But if I go to my automated test case tab here, you can see all of the different steps that I performed during the test. I've got a screenshot of every step that I performed. And up here in the top right-hand corner, I can export my Appium script. So you can see that the Appium script is already available for me to download. It'll download in a zip file. I can upload that into my IDE and then immediately run this test again against the same device or different devices, that manual test that I just ran. What I'll do instead is use our scriptless automation to run that manual test against other devices. So I have created a device bundle of devices running Android 10. As you can see, I've got a couple different screen resolutions here. I'm going to select these two devices and run my scriptless sessions. So the AI now will run that manual test that I just ran against these two devices and show me the results. It takes just a moment to run. And once the tests have run, the AI will go back and compare the screen on the manual test against the screen during the automated tests, and it will notify me of any differences that it sees. So once these have finished running, I will be able to pull up that validations list and show you differences that the AI picked up between the manual test and the automated test. So it has already populated several validations here. I have text validations, so differences in text size and wrapping, things like that. I have visual discrepancies, performance discrepancies. So if there is an issue with different pages loading and it exceeds the threshold that we have set, that is brought to your attention. And then we have accessibility validations, which go into anything that may be or cause issues with your application being W3C compliant. We can take a look at a couple of these validations here. It looks like so far it's found a text validation and 2 color validations. And each validation will show me side by side the manual test and then what was found on the automated test, and what is different. So it looks like with this one, the wrapping was different. Okay, so these are the kind of validations that we would bring to your attention. Color validations also, if there's a validation or if there's a difference between your text or your font color between the manual test and the automated test, we would bring that to your attention as well. And I would like to show you at least one accessibility validation. So currently we will show you color contrast issues and touch target size issues. So with one of these color contrast issues, we're saying that right here, the font color and the background color might not be different enough for someone to be able to distinguish the text. So these are the kind of accessibility validations that we'll bring to your attention on every Scriptless test that is run. Frank, is there anything else you would like for me to review regarding the validations here?
No, Mark, this is great. I just want to point out some things that Mark just went through. Sometimes the simplicity of it makes us gloss over some of the power. What Mark just did was, in a matter of 5 minutes, he ran a manual test on one device, on a specific mobile app, on a real device. He then performed a scriptless automation that reran those same test steps across 2 other devices. And in real time, Nova was analyzing the output of those other devices to automatically identify differences between the manual test and the revisits on the scriptless side. And he pointed out the text wrapping. And he also showed the accessibility that was assertions that or validations that were run in real time. All of that in a matter of 5 minutes, what would typically take days if you're starting new with Appium and writing all this from scratch. So, Mark, thank you so much for the demonstration. And it looks like we've got some questions coming in about how we do that Drew will go through later. So I will come back and present the next, the last part of this, which, this webinar is going so quickly because it's so easy to use. But what sets apart Nova from the other AI-based testing tools? And when I look at Scriptless, I think there are 3 general approaches. One of the biggest challenges with Scriptless is knowing what's different between how different products support the capability. And we're going to talk about 3 categories. The first is bots. The second is a Scriptless approach called step composition. And the third is the one that Mark just went through, which is the manual test capture. And so let's talk about the bots. With a bot-based approach, the bot will go through and perform all of the steps that they can in a depth search method. So it will find the elements on the first screen, click them, try to go as far through an application as possible, and then it'll just navigate itself around as best it can. The problem with bots is it lacks context. So it's just, it's not a very intelligent bot. And oftentimes you'll see products get stuck in a loop. So they never end, they just keep going around, and you can see if you watch some of these products that they keep going back to the same previous step, and then they go through their depth first search mechanism and they don't realize that they're back to where they started. Probably the biggest issue though is the limitations around credentials, because many apps have some sort of registration or login process. It really limits what you can do using bots. And finally, pop-ups plague bots just because they're not handled well. The bot doesn't understand that there is a pop-up on the screen and tries to click on other elements on the screen. Like when I went through the overlapping elements, this becomes a big problem with bots. Now, the advantage of bots is you can just run it and it kicks off and does its thing autonomously. And it can detect simple issues with the app, like security, visual contrast. But we have a partner who's one of the leaders in the security industry that performs security, both dynamic and static validations. And it's they don't even use bots to do their analysis. They actually have scripts that go through the application because of the issues that I went through before. Who's using bots today? Bitbar is using them. Probably the one I've seen used most popularly is Google Android Play Store. If you launch an app in the Play Store, Google will go and analyze your application. It doesn't. It assesses it based on accessibility and performance, and so response time. And it does some items around security, but it doesn't go very far in apps because of the credentials issues that I talked about earlier. The next approach is for Scriptless is step composition, and definitely a much more popular Scriptless approach. And what it does, at its foundation, if you go back to where I was composing a script through a manual session where I would have the Appium Inspector up and running on my right-hand side, and then select an element, choose an action. That process for these step composition approaches is making that process much easier. So with these types of applications, you choose the element that you want to interact with. You say, here's the interaction I want to perform, like tap, and then that will go and add that to your script, and then you can export that script, or you can in some cases you can export. In many cases, you just rerun those same steps using their scriptless automation solution. So tap on the this element, enter phone number or email field, and then enter text, and then you would enter the text. So it's not strictly performing the manual capture, but it is making the composition process easier. So one of some of the issues with step composition is it's not intuitive which element to choose always. You know, when you click on an element like a button, the developer may have created 2 or 3 layers of XML within that button. So it's not obvious which element to actually choose. You can do it for a single device reliably, but you start to run into issues when you have different screen resolutions and elements move around. You have to scroll. You know, one of the things that Mark demonstrated was the scrolling capability within Nova Scriptless. So, you know, he doesn't need to have to specify the screen resolution. It just Nova knows how to do it automatically. With step composition, you're limited on the screen resolution that you're working off of. It is more time consuming than just performing a manual test. You're actually going through and doing 3 steps for every single manual test step that you would normally perform. And then finally, pop-ups become, you know, I'll mention this over and over again, pop-ups seem so benign, but they are the cause of many automation failures. When pop-ups, like an entitlement pop-up appears, this becomes problematic across different across different operating systems. Now, some of the advantages of step composition is you can create reusable components. So you can say, I want these 3 steps to be the login steps, and then I want to piece that together with the checkout function. So, you know, that is a very nice capability within step composition. And it gives the tester this is in comparison to the bots, he starts to put the tester in control of composing or authoring the test case or the test script, which you didn't have in the bots approach. Who is using step composition? Both Testcraft and 21 Labs were acquired by Perfecto or Perforce. So they're very much focused on that step composition approach. Test.ai is also a step composition solution, as is Catalan. Kobiton is a Catalan partner, and you know, if you want to take the step composition approach, when you perform on real devices within Catalan, those are actually hosted by Kobiton. And I think it's important not to confuse web and mobile here, because it's when you actually go to rerun those same tests in the step composition approach across different mobile devices, this is where you end up having quite a lot of issues that you wouldn't have in the web world when you look at tools like Mabel and Functionize, who excel in scriptless automation on desktop browsers. And the final approach I'm going to spend some time on is the approach that Mark demonstrated with Nova, which is the manual test capture. And that is simply, and you know, simply in terms of how easy it is to use, simply a matter of performing a manual test, and then Kobiton, or this solution, captures all of the steps and then can rerun those same test steps on a multitude of other device types. The most common, the 2 companies that are using manual test capture are Kobiton and Waldo. And I'm going to talk through the differences, but between Kobiton and Waldo, because the way that it's implemented is slightly different between the 2. So Waldo uses a machine learning technique called instant segmentation that looks at the screen visually and determines which element was interacted with. So if I click on a button, it's able to identify that as a button. And when I rerun across other devices, if that button is visible, on that screen, it's able to match that across different screen types. So Kobiton uses instance segmentation, but it adds on to that the XML extracted from the device. While you're performing a manual test, like what Mark was performing, the screen is being captured. So we're taking a screenshot and we're extracting all of the XML of what's used to render that screen on the device. That helps with results because it's more data for the machine learning models that we have to identify the element and identify that element across device types. It also provides the ability to export an Appium script. In the case where, like with Waldo, where you're just using visual cues, you don't have the ability to export that Appium script. So, one of the things that when Mark was going through, Nova is able to automatically identify which element was being selected. So we have a deep learning model that identifies when you've got overlapping elements, which one was intended to interact with. And that takes that in the test step composition, some of the complexity or the grokking of which element is it, it takes that complexity out. So making the manual testing and the ability to compose a test script seamless. So the traditional methods of capturing the XML are pretty slow. We've invested heavily in making that really fast. So there's no visible impact on your manual session, and that, as Mark showed, you can export an Appium script within seconds after this manual session ends. And we support cross devices, right? So we map elements across devices. And if we aren't sure, we ask you to annotate, and that annotation is used to improve your app on subsequent executions. Our Flex Correct, which we've launched this year, is a self-healing capability that when you have a new version of your app, if the developer changes the XML or the hierarchy at all, Flex Correct automatically identifies the element. And so our goal here is to get rid of the element not found errors that cause more than 50% of flaky tests. And then pop-ups, I'm going to close this off with pop-ups because I keep talking about it, but we have a Popup Detector that maps pop-up prompts and actions across different device types and operating system versions. So if it's the Wingman app would like to access, or the Vroom app would like to access your location, you can, in some versions of operating systems, the response is accept, and others it's okay, others it's once or the first time. So we map that, and if you're performing the manual session on one operating system version and it changes, that prompt changes to other operating system versions, we automatically determine that and take either the affirmative or the negative selection. And then we are adding support for probably the other cause of we've seen is random application pop-ups. This is things like, would you like to rate the Vroom app that pop up, or maybe it's some sort of advertisement or promotion that's appearing. So you can automatically dismiss those so they don't cause your automation scripts to fail. And then, the other common issue with mobile and web is dynamic content. So being when like a media app, a CNN, that renders the same style of the page, but the content within each of the elements may differ from either based on location or based on time. So we have some capabilities to allow it to be creative, and then we can infer dynamic content from previous executions so that we don't cause failures to occur. One of the things that you saw with Mark's demonstration is that he scrolled down multiple pages. With Kobiton's capability, we have the ability to identify the element even if it's on different positions. One of my favorite demonstrations is with the REI app, where there is a boot that the user is selecting to purchase that's on the first page on the right-hand side during the manual session. During one of the revisits the next week, where the content has changed, that boot has moved to the third screen on the left-hand side. So Nova automatically goes through and scrolls through to the third page. Right now that's configurable, but it can scroll up to 20 screens down to identify which element to choose, which is the best one to choose. And it chooses the same boot that's on screen 3. We're also stitching images of the scrolls. So this is something that's being released in our April 23rd release that stitches the images during scrolling. And so you can actually compare visually across not just the first screen, but multiple screens that are rendered as part of a test step. So thank you very much, Drew. Do we have any questions?
Yeah, actually, we've got quite a few, so I will just try to go in sequential order here, and hopefully we get to all of them. So first question is, does Nova Scriptless Automation support hybrid mobile apps?
Yes, we do. We support native, hybrid, and pure browser testing within a mobile device. It's supporting the web context within a native app is a complex topic because of the mapping of coordinates, but we've invested heavily to make Nova support those different contexts.
Great. Does Nova provide only XPaths, or are there other technical identifiers like class IDs or unique IDs of an object?
Currently, we export the XPath. We do have an enhancement that will be released in the second quarter of this year, so by the end of June, that supports other identifiers. And when you export, you can choose which identifier and sort of an identifier hierarchy to use.
Are there specific tools to install the inspector on the dashboard?
Are there specific tools to install the inspector? I see. No, so let me go back to that screen. I'm going to share my screen again. And I did want to show one thing that wasn't demonstrated before, but the other thing that you can do after this session has ended. So here was my manual session. This is Session Explorer. Session Explorer is Kobiton's ability to use an iMovie inspired interface to render the test session. Along the bottom is the timeline panel. This shows all of the test steps that were performed during the manual session. I can zoom in and out of, if I've got a long session and I've got a lot of little steps, to zoom into specific timeline. The upper right is the screenshot panel. That shows the screen that was rendered at that point in time and the action that was performed. So here you can see a tap. If in Mark's demo, he scrolled around. In the upper left is our insights panel. And here you can choose different insights of the session. You can look at system metrics, you can inspect elements. I am going to just reload this. So here you can see the system metrics appearing now. I had to just refresh. Kobiton's the only product where you can inspect elements from after the test session completed. So here I can show you that you can inspect elements within web contexts. So you've got these web contexts within this Vroom app, and I can go in and select any of these elements. So you can inspect elements if you had a failure after this session ended. But going back into how do you inspect elements within Kobiton, we have right now in our public cloud, a lot of our devices are on the previous version of Kobiton. We are upgrading all of our devices to a version that includes the part of the acquisition that Kobiton made last year of a company called Mobile Labs that has excellent technology for inspecting elements and capturing device metadata. So some of those devices that I launched earlier didn't have it, but this Note 10 does. By the end of June, all of the public cloud devices, the ones that you can use on a permanent basis, will have that Appium Inspector.
Awesome. Okay. Let's say the Appium Inspector is unable to find the page element on the iOS app on the React framework. Then what is the other solution?
Come again? Can you repeat that?
Yeah. So in a scenario where the Appium Inspector is unable to find the page element on an iOS app using the React framework, then what's our other solution?
So there is an Appium, so let me go back to share my screen. I think the question is if the inspector cannot find the element. So I'm going to answer that because I'm not completely clear, but I'm going to answer that in possibly two ways that the question might be, but I'm going to install a React Native app. So this app was built using React Native, and I can go into Inspector once this app installs. And I can now inspect elements on this screen. And if I want to highlight over here, I can. So I'm not, so that's, we can identify elements within Appium Inspector, within our device inspector here. I think the question was if it couldn't find it during the revisit, what would happen? So in that case, when you're in a revisit and it doesn't find the element, we will ask the user to identify the element through a remediation request. So if the RAI falls below a confidence level, it then asks the user to select it, and then we will rerun using that selector.
Great, thank you. Okay, does the pop-up detector on the app need to be turned off on the code level, or when recording the script, can it bypass the pop-up and execute the rest of the steps?
Yeah, so it doesn't need to be done at the code level. It's all done. Currently the operating system pop-ups. We have a set of default pop-ups that we apply, like that bypass the operating system upgrades. So, nobody wants. We don't support the test case where an operating system pop-up is present, but that's usually more of a nuisance than a test case. So we bypass those automatically. And then for any entitlement pop-ups like location entitlements that are part of your app, whatever you choose during the manual session the same action or equivalent action will be chosen during the revisit. An affirmative maps to an affirmative, a negative maps to a negative. In the case that we currently do not support in Nova, the dynamic pop-ups that are more part of an application flow. And those, like I mentioned, we'll be supporting later this year.
Great. How can failed or blocked scriptless runs be rectified and or fixed?
Yeah, so there are two types of failures. One is when AI is a non-deterministic capability, right? So unlike deterministic flows like 1 + 1 = 2, in the world of AI, and I think this has been one of the biggest challenges in the world of scriptless automation, is getting the world to appreciate that there is going to be a training period where the tester has to train the AI to do a better job. So this is a great question because it focuses in on, what if you do have this imperfect case, the case where it chooses the wrong element or can't find the element. So in that case, providing the ability to annotate, to make annotations to the user interface is a differentiator of Nova, right? The ability to say this element or this selection that was made by Nova needs to be changed. You can do that quickly using the annotation interface, or if Nova's not sure, being able to direct it using a remediation. A remediation request will be sent to the user, the tester, and then they can annotate that to choose the right element so that the test can be rerun. I didn't really talk about it much, but one of our whole Nova's AI has this an index of your application that is an AI generated index. That index is used as part of FlexCorrect, which is our self-healing capability. So if you run the same scriptless capability against a different screen resolution or a different operating system or different device type, FlexCorrect kicks in and says, even though this selector, whatever the selector is, usually it's XPath right now, whichever it is, isn't present, we will use our AI index to determine the next best element to choose.
Great, okay. When we enter a password, is it showing the actual characters on the automated test cases? And will there be an encryption option for such sensitive data?
Yeah, so let me go through. Do you see my screen now?
Yeah.
Okay, great. So yeah, so one of the capabilities when you're entering a password is you can enter sensitive data. So I'm going to go ahead and install this app again. and show how that works. So any sort of any text that's can be entered in as sensitive data, and when that is entered in, like let's say I wanted this text field to enter sensitive data, like I can go ahead and just enter some data. I can show it here, and then I can send this to the screen by entering save. That text will not appear in the revisit session, and it will not appear in any of my Session Explorer results. So this is a way to send sensitive information through, but hide it from all users.
Awesome. Okay. Is the Appium script that you download proprietary, and can it only be used with Kobiton?
No, that's a great question. There's nothing proprietary about it. If you wanted to use Kobiton to simply run a manual session, export an Appium script, and you wanted to export that to run against Sauce Labs or Browser Stack, you can do that. We don't think you'd want to, because our version of Appium runs 3 times faster than our competitors. But if you ever wanted to leave Kobiton, there's nothing that ties you in to Kobiton. It's completely open source and proprietary. It's all yours.
Awesome. Okay, one more technical question, and I think we'll wrap after that. So, how does Nova handle the dynamic changing elements during a test? For an example, in e-commerce apps when product changes happen rapidly.
Yeah, so what's being referred to as dynamic content, and I distinguish between dynamic content from animated content. Animated content, has some sort of animation that shows up on the screen. Dynamic content, which is where the question is focused, is from one version of the app. One day to the next day, the content changes, or you see this a lot with media applications where the content changes based on location. And how does Nova handle that? Currently, any dynamic content that is interacted with, you can choose that as dynamic content. So Nova will not evaluate it based on its visual content, but will look at more of its non-visual content, the XML and the XML hierarchy. And then you also have the ability within Nova to say, be creative. There's an option that's more of a bot-like feature, which is just, if there is dynamic content, you can say, I want you to choose that the best content that you can think of for that given selection. Over multiple iterations of your test, what our AI index is composing is this ability to infer which fields are dynamic and which ones are not, so that when you do subsequent manual tests, we will automatically know that that's dynamic content, and we won't have to prompt you for to remediate any blockers, because we can automatically infer that field is dynamic.
Awesome. Okay. So we will wrap with that. Thank you everyone for the amazing questions. Any that we did not get to, feel free to send them to marketing@kobiton.com, and we will make sure that Frank has an opportunity to answer those for you. But in the meantime, again, thank you everyone for attending this webinar, a recording will be sent out to everyone who's registered. So any of your coworkers or peers that weren't able to make it today will be able to view this webinar as well. Frank, Mark, any last minute comments before we wrap?
No, thank you very much, everyone, for attending.